All right. I'm going to show you how compounds are going to look on your test in two different ways. First, I'm going to show you with scientific notation, and then I'm going to show you kind of a visual depiction of the way that it looks. Now, if a chemistry teacher sees me do it this way, they are going to laugh because I will not do the proper molecular structure, okay? But it will get the idea across. So I'm going to start off first with the scientific notation of a compound. All right. Now, it is KNO subscript 3. This is one molecule of a compound. How many elements does this molecule of this compound have?
3.
It has 3. K, N, and O. So it has 3 elements. All right. Now, how many atoms of K does it have?
1.
How many atoms of N?
1.
And how many atoms of O?
3.
Okay, so if I wanted to draw it visually, I could use red to represent K, use blue to represent O, and why am I making sure that they touch? Because they're bound together chemically. Good. And then I'm going to use this color as my oxygen, purple, and it would look something like this. Now, how many atoms total are in this compound?
5.
5. There's 1, 2, 3, 4, 5. Or you could add them up right here. 5. Now, I am going to imply that I have more than one molecule of this compound. So I'm going to put a giant 3 in front. This is a coefficient of 3. So what that would mean is I have, see this right here, this one molecule of that compound? I need to make 3 of those now. So if I had 3 KNO3s, how many atoms would I have total?
2.
How many, Chris?
2.
I would have 15, because all Chris did was he took the 1, 2, 3, 4, 5. I have 3 of them, so I would have 15 atoms total in 3 molecules of that compound. All right? Now, is this a compound? H2O.
Yes.
H2O is. How many elements?
2.
How many atoms?
3.
Okay, very good. All right, is this an element, a compound, or a mixture?
Compound.
It's a compound. How many elements are in this compound?
3.
3. 1, 2, 3. Remember, we don't count the little letter. That's not its own little guy. And how many of nitrogen do I have?
1.
How about hydrogen?
4.
How about beryllium? So how many elements total?
6.
Elements total?
3.
3. Atoms total?
6.
6. All right? So we get this. This is easy, correct? Now, in order to show the law of conservation of mass, I would have to have the same on each side. So I would need 1 nitrogen, 4 hydrogen, and 1 beryllium on this side. So it doesn't matter how they're arranged. I could do Br plus, and I could do 4, and let me mess it up, 4NH. Now, is this balanced?
No. No.
Okay, well, how many elements do I have?
3.
1, 2, 3. Okay, well, that checks out. I have Br. How many Brs do I have?
1.
All right, I have 1 there, 1 here. That works. Okay. How many nitrogens do I have?
4.
Okay, well, this is working out. Oh, wait.
Yeah.
How many am I supposed to have?
1.
1. So this is not balanced. This does not show the law of conservation of mass, or LOCOM as I put it on your test. Okay? Now, in order for the law of conservation of mass to be true, I have to have the same amount of reactants, which is this side, reactants, as I do products, which is this side. So if this side weighed 24, I'm going to just say grams. If this side weighed 24 grams, then what would this side have to weigh?
24 grams.
24 grams. And you guys are friggin' geniuses.